Hi math students! Today's lesson is going to be a review lesson on all of the things we learned about with integers, specifically how you add, subtract, multiply, and divide integers. So to begin, we've got our objective, which like I said is how you add, subtract, multiply, and divide integers. We are going to start off with the two skills we learned in Unit 1, which were adding and subtracting integers. And to help us remember some of the things we mentioned, I've got 3 real-world problems to look at. The first one says the temperature outside when Denise went to bed is 2 degrees. Overnight, the temperature dropped 5 degrees. What is the temperature in the morning? I've also included this number line over here. I made it vertical so you can kind of think of it like a thermometer to help you figure out the answer for this. Well, what do you think? Well, we've got the temperature was 2 degrees, and it tells us the temperature dropped 5 degrees, which means it's going down 5 degrees. What was the temperature? Well, one way you can think of this is with our number line / thermometer over here. The temperature was 2. We want to go down 5. 1, 2, 3, 4, 5. Which leaves us with a -3. We've got 2 other quick ones. Same idea about temperature. I've just changed the numbers a little bit. So for number 2, we've got the temperature outside when Denise went to bed was -2 degrees. Overnight, the temperature dropped 5 degrees. What was the temperature in the morning? Same idea, except now this time it's -2 degrees. So we've got -2. It dropped 5 again, which is -5. You could also do this one with the number line if you like. It's starting here in the -2 and it's dropping 5. So it's going 1, 2, 3, 4, 5. That leaves us with a -7. We've got the last one. Again, the temperature outside when Denise went to bed was -2 degrees. Overnight, the temperature rises 5 degrees. What is the temperature in the morning? Well, this time we've got it starting at -2 degrees. The difference for this one is it's rising 5 degrees. So this time it's going up. We're adding 5 degrees. If you do that, if you want to think about it again with the number line, -2 is right here. It's rising 5. So we can go 1, 2, 3, 4, 5, which leaves us with 3 degrees. Now the reason I've got these 3 problems, I know they all were very similar, but I changed the numbers around a little bit, was to show you the second way we had talked about adding and subtracting integers. One way was with a number line, but in that lesson we had mentioned how number line's really great if you're a visual person because you can see what's happening with those numbers. But the problem with the number line is, what if the temperature when Denise went to bed was 100 degrees and overnight it dropped 35 degrees? That I would need a much larger thermometer / number line, and it would be a lot more counting. Could also give you decimals, fractions, and again, that's harder to use a number line for. So I chose these problems here to show you the other way we talked about doing these, which is with our integer rules. One of the rules we had was if the signs of the 2 numbers are different, so like this problem where you have a positive and a negative, or this one where you have a negative and a positive, different signs means you would subtract the numbers. So notice if you subtract a 5 and a 2, you get a 3. If you subtract a 5 and a 2, and you get a 3. And then we said you keep the sign of the larger number when you're talking about adding or subtracting integers. Here the larger number was 5, which was negative. So our answer was negative. Here the larger number was, again, 5, but here it's positive, and our answer was positive. That was one of the rules we had. The other rule we had said if both numbers have the same sign, like here where they're both negative, same signs means you add the 2 numbers and then you keep the sign, that negative sign there. So I've chosen these 3 ones because I think it's a little easier to think about these problems when you think about temperature or money is what a lot of students ended up using to help them. But we've got those rules there that will apply for any problem, even if the numbers get larger or have decimals in them. One of the things I think that was most confusing for students with this is sometimes you're seeing a minus sign, but you're actually having to add the numbers. And sometimes you're seeing a plus sign, but you're actually having to subtract the numbers. Always go by the combination you have. Different signs means you're subtracting. Same signs means you're adding. So to kind of put down all these things we've been saying, I've got the first two rules we had learned when it comes to adding and subtracting integers, where if both numbers have the same sign, we went ahead and already said it, you want to add the two numbers and keep the sign. And then we said if the numbers have different signs, you want to subtract the two numbers and keep the sign of the larger number. So these were the first rules we learned back in Unit 1 for this class. Keeping in mind those rules, what you saw with the number line, what you already know about this, I've got some questions we'll go ahead and use as practice problems. Go ahead and try 1, 2, and 3 for me. All right, for number 1, -3 plus 4 would be 1. You can think about it on a number line. You can think of it with the rules and say, well, different signs means I'm subtracting and I'm keeping the sign of the larger number. Some people like to change these into like money problems. If I owe you $3 and I have $4, well, I would pay you back and then I would have $1 left. Lots of different ways you can do these. The second one, 9 minus 11, well, we're subtracting a larger number, which would leave you with a negative. It would be -2. Number 3, we've got a -5 plus -5. Here they are both negative, so we're just getting a larger negative number. You would want to add them and keep the negative sign. If you're using your rules, they have the same sign, so we're adding and keeping the sign. If you're thinking about money, this says I owe $5. Oh, well, now I owe another $5, so I owe a total of $10. Now that we've done those first 3, the next one is one of these compare using an inequality problems. One of the things I noticed that was missing from a lot of people's answers in Unit 1 was this idea of justifying your reason. And the other thing I saw students having a little bit of confusion on is what an inequality is. Remember, inequalities were those less than and greater than signs we learned. So what it's asking you to do is choose what inequality sign should go right here to compare these two amounts. When it comes to justifying, well, just tell me what you did to figure that out. So here, you're probably going to have to figure out what this side equals and what this side equals. So in your justify, you could tell me that. You could say, well, I figured out this left side equaled whatever the answer is. I figured out this right side equals that, and I used those numbers to figure out if I want the less than or greater than sign, something like that. Go ahead and try this one for me. Make sure you include both parts, the inequality sign and the justify. Okay. Well, over here on the left side, we've got -4 plus 5. Those are different signs, so you're subtracting and keeping the sign of the larger number, which is positive. It's really just like 5 minus 4. Over here on the right side, you've got 6 minus 9. You are subtracting a larger number, which means it's going to be negative. That's going to end up being -3. Now, once you know the left side is 1 and the right side is -3, now it's really easy to pick your inequality sign. 1 is positive, and positive numbers are always going to be greater than negative numbers. So I could say 1 is greater than -3. Now, when it comes to my justify, there's lots of things you could say here, but I would probably say something like -4 plus 5 equals 1. And 6 minus 9 equals -3. All I did was write down the math I did. And then for the second part of this, well, how did I come up with the sign? I could say, I know 1 is greater than -3. You could even say why. So I had mentioned earlier, I know 1 is greater than -3 because 1 is positive, -3 is negative. But I could just finish this up by saying, I know 1 is greater than -3, so we need the greater than sign. And there you go. I've had a lot of questions about like, well, I don't know if what I'm writing is good enough, or I don't know what it means to justify, so I'm just leaving it blank. It doesn't have to be some crazy, beautiful English paragraph here. Just tell me the math you did and how you used that math to help you out. Okay? There is one last one for us to look at. All of these were just like straight number problems, right? There was no story with them. The last example we've got is a review of what we learned about with integer word problems. So, whoops, sorry, tripping. So this first one here says, poor Steve checks his bank account on Monday and sees that his account balance is negative $125. Part A is asking, what does a balance of negative $125 mean? Well, if your bank account is negative, we had a lot of examples with these. If your bank account's negative, that means he owes $125. You could say he owes $125. You could say that's money he doesn't have. It's money he needs to pay the bank. Something about it being the opposite of that's his money, right? It's money he doesn't have. It's debt. Part B says Steve deposits $80 on Tuesday. What is his new balance on Tuesday? Well, first off, he owes $125. If he deposits $80, is he still going to owe money? Yes or no? Well, yeah. He's depositing money, which is helping him get out of the hole. It's helping him not owe money anymore. But he owes more money than he deposits. What that tells us is our answer is still going to be negative. We've got the negative $125 he's starting with. He is depositing $80. That's money he does have, so it's positive. If I write this down, I have different signs. That means we want to subtract, which goes along with what we were saying, right? It means his debt's going down, so I do want to subtract. If you subtract 125 minus 80, 5 minus 0 is 5, 12 minus 8 is 4. That gives you 45. Now remember, we said the debt he has is greater than the money he's depositing. That negative number is the larger number. That's telling us that our answer should be negative. What's that saying is, well, he's depositing $80, so his debt has gone down, but he still owes money. He still owes $45. One last part, Steve deposits another $80 on Wednesday. What is his new balance on Wednesday? Well, same question as before, but a different answer, right? He owes $45. If he deposits $80, he's out of the hole. He no longer owes money to the bank. He's positive. So right away, I should know my answer is going to be positive. It'll look similar to what we did before. I'm taking his balance and I'm adding 80 in. Also, like before, we have different signs here. So I want to subtract. Hopefully that makes sense, right? This is money he has, but he's got to pay the money he owes the bank first. That's why we're subtracting. So I could say 80 minus 45. I have to borrow from my 8 and make it a 7, and then change my 0 to a 10. 10 minus 5 is 5. 7 minus 4 is 3. So we get 35. Now remember what we said about the sign? That's money he has. He pays the $45 he owes, but he'll have some left over because that 80 is the larger number. The 80 is positive. So my final answer is positive. Positive 35, meaning his bank account is $35 and he actually has money now. He has $35 in the bank. He no longer owes money. Money, I think, has been, for this group of students who's watching this video, money has been like the easiest thing that's helped students think of negative numbers. So when in doubt, if you're looking at a problem like this and you're not sure what to do with the numbers, try changing it into money to help you figure it out. I think that's because, you know, we're all adults. We handle money a lot. And you guys have got a lot of common sense when it comes to money. So take advantage of that common sense. These were our examples on adding and subtracting integers. Like I said, this is something we covered back in Unit 1. Last week on Thursday, you guys saw the lesson on multiplying and dividing integers. So as a quick reminder of what we said in that lesson, we said for multiplication and division problems, if you multiply or divide two numbers with same signs, the answer is positive. And if you multiply or divide two numbers with different signs, The answer is negative. So using those two rules, we've got a couple questions we'll look at. This first one is asking you to compare the two problems. We've got this and this. I'm not reading them intentionally. And the question is asking, are these problems the same or different? Explain your thinking. Go ahead and try that now. All right. One of the things this question is focusing on is what we talked about in that lesson with parentheses. So one of the things we learned in our multiplying and dividing lesson is sometimes parentheses can mean multiplication. It's going to depend on how they're written. If you have two sets of parentheses like this, where they're right next to each other, there's no like addition or subtraction sign in between them, this is multiplication. This problem right here is a multiplication problem. It says -3 times -5. This one here has a sign between the parenthesis and the 5. That one is not a multiplication. This problem here just says -3 minus 5. Sometimes you'll see parentheses around a number with a negative sign just to say like, hey, this is a negative sign. It's not a subtraction sign. It's with the number, but it doesn't mean multiplication. And I think the difference between how these problems are written can sometimes confuse students, hence why we're practicing it now. So this one right here is not multiplication. This is just the same thing as -3 minus 5, which is what we just finished reviewing. They're both negative, so I'm going to be adding and keeping the negative sign. This other one here is multiplication. We know 3 times 5 is 15. And then we just said a moment ago, if you're multiplying the same sign, your answer would be positive. So we get positive 15. So to actually answer the question, are these problems the same or different? We would say that they're different. If you wanted to explain why, you could say -3 minus 5 is a subtraction problem, right? It's saying minus 5. And you could then say, I'm not going to write all of this down, but you could say -3 minus 5 is a subtraction problem. It equals -8. And then you could say the -3 times -5 is a multiplication problem, and it equals 15. If you wanted to elaborate, like if that's where you're already at with these written responses and you want to push yourself even further, you could elaborate by saying how you know. Well, how do you know that this is a multiplication problem? Well, we said it because there's two parentheses right next to each other. How do you know this is a subtraction problem? Well, because there's that minus sign in between the first number and the second number. It's -3 minus 5. So if you feel like you're already at what I just said, you can push yourself even further by explaining the why. We love hearing the whys. There's one last one. Again, it's one of these compare with an inequality. We did one of these earlier, so hopefully you'll find this one a little easier. This one here says, use an inequality to compare the following. Justify the reason you chose that inequality sign. And we've got these two problems here that you want to compare. Go ahead and try. Make sure you answer both parts of the question. All right, how do we do? Well, the first one, this right here, I've got a number right next to a parenthesis. That is a multiplication problem. That is -4 times 5, which gives me -20 on that left side. On the right side, it just says -20 minus 5. No multiplication. They're both negative, which means I want to add those numbers. And then they're both negative. It means we're just adding and getting a bigger negative number. So my answer would be -25. We want an inequality sign to compare those two amounts. This was another area students struggled with a little bit. If you're looking at two negatives, knowing which side is more, I'm going to say the same thing I said a couple minutes ago. If you struggle with knowing which side is greater, think about it with money. Would you rather your bank account say -$20? Or would you rather it say -$25? Or you can think about it with temperature. Which temperature is higher? I know they're both very, very cold, but which one is warmer? Well, if you're thinking about money, if you're thinking about temperature, if you're thinking about just a normal number line, this number here is greater than -25 because this negative is closer to 0 the negative 25 is. So for that justify, what could we say? Well, we could say first we did negative 4 times 5, and that equaled negative 20. And then we did negative 20 minus 5, which gave us negative 25. What inequality sign do we want to use? Well, I could say negative 20 is greater than negative 25. I would love to hear how you reasoned that out too. Were you thinking about money? Were you thinking about temperature, a number line? How do you know that that was greater than? And then we could just say, so we need the greater than sign. Something like that. Another reason, if I have not convinced you enough to justify your answer, another reason why it's really helpful is because usually questions like this are 2 points. 1 point for the inequality sign and a second point for the justify. If you give me the wrong inequality sign, but your reasoning here is right, like maybe you did all the math right, but you thought this sign was greater than, I can give you some of those points. Or let's say you did one of the math problems wrong, but everything else was right, I can give you one of those 2 points. But if all you say is this, and you don't give me any reasoning, I don't know where you went wrong, right? I don't know if you just had no clue and you just guessed something. I don't know if you were super, super close, but maybe you forgot the negative sign and so therefore the inequality sign went the other way. I don't know, I'm not in your head. So that's another reason why we ask you to justify, is it helps us figure out where you're at home. And on my end, I can give you more points if you're really, really close, just like a little off. So I'm going to erase all this. There was one last rule we learned in Unit 1, which was on subtracting a negative. We learned that subtracting a negative is the same thing as adding. And at the time I talked about, it's like taking away a debt. If you had $3, you owed me $4, but I took away that debt, that instead means it's money you end up having. Instead of money you're paying, you have it. Another way we can talk about this now, why this is the same thing as adding, is now that you know that if you multiply a negative and a negative, it gives you a positive, you could also use that. We've got a negative sign times a negative sign. Well, negative times negative gives you positive. So just another way to think about it now. Either way, 3 minus negative 4 is the same thing as 3 plus 4, which equals 7. So that's one example. You go ahead and try this next one, which says negative 3 minus negative 1. How'd you do? Well, same as before, that negative and this negative turn into a positive. Subtracting a negative is the same thing as adding, or you can think negative and negative give you positive if you're multiplying. That leaves us with negative 3 plus 1. Well, negative 3 plus 1, they're different signs, so I subtract and keep the sign of my larger number. So we get negative 2. And those were all the rules we learned for integers. There are a total of 5. 3 for adding and subtracting, and then the 2 for multiplying and dividing. If you have not already somewhere in your notes written down all the rules, I would write all 5 together just so you've got them all in one place. Like I said, integers are something that students struggle with the most when they first come back to school, especially if you've been out of school for a while and it's something you never felt confident at. So please ask us for more practice if you're still not feeling good about this. In school, we usually give students a lot of practice on these, just because, like I said, it's something that students find a little more challenging when they first come back. The last part of this is I have mixed together addition, subtraction, multiplication, and division problems. And so we are going to look at something like this. Notice I kept the numbers the same. I just changed the way they looked and changed the signs on some. There are 6 problems here. Go ahead and try all 6, and then we'll talk through how you did. Okay. This first one, they are different signs. So we want to subtract, which would leave me with 4, and keep the sign of the larger number. Again, you can also think about the addition subtraction problems with like money. I owe you $8, I have 4. Well, I'll give you my $4 and now I just owe you 4. The next one is a multiplication problem. I know 8 times 4 is 32, and we learned with multiplication, if the signs are different, the answer is negative. The next one says negative 8 minus negative 3. 3, that's a 4, I'm sorry. Negative 8 minus negative 4. We just saw that last rule that says if you're subtracting a negative, that is the same thing as adding. So this becomes negative 8 plus 4. Notice that's the same as up here. Negative 8 plus 4 is negative 4. This next one is written with that slash, which we learned in the multiplication and division of integer lesson. That slash means division. Negative 8 divided by 4. Well, I know 8 divided by 4 is 2. And different signs when you're dividing gives you negative. This next one here is similar to up here, where that's subtracting a negative. Those two negative signs become one big positive sign. So that leaves us with 8 plus 4. 8 plus 4, you guys know, is 12. This last one here, negative 4 plus negative 8, they are both negative, so we are adding and just getting a bigger negative number. You could think about it with money if you want. I owe you $4, now I owe you $8, so I owe you a total of $12. I like doing these sets where like the number's the same, but we just change how it's written a little bit because I think you can really focus on the rules and how the problems are written. I've got one more like this. Here we go, a bunch of 16s and 4s. Go ahead and try these 6. All right, how'd you do? Well, that first one, we've got a number right next to a parenthesis, so it's multiplication. You might not know what 16 times 4 is, and that is okay because we can multiply it. 6 times 4 is 24. 4 times 1 is 4, plus that 2 gives you 6. So that leaves us with 64. We are multiplying different signs. When you multiply different signs, the answer is negative, always, always. The next one says 16 plus negative 4. If I look, the 16 is positive, the 4 is negative. They're different signs, so we want to subtract, which would give us 12. And since my larger number is positive, my answer should be positive. If you're thinking about money, this is like I have $16, I owe 4, so that leaves me with 12. This next one, we're subtracting a negative again, which we had seen in those earlier ones, becomes addition. So we're left with 16 plus 4, which you guys know is 20. That next one, we've got the slash again, which we saw means division. Negative 16 divided by negative 4. Well, I know 16 divided by 4 is 4. What do you get when you're dividing two negatives? A positive. Dividing two negatives give you a positive, so we're left with positive 4. That next one, negative 16, and then there's that little dot we learned means multiplication. So this is negative 16 times 4. I already did that multiplication, so we get 64. And then notice we're multiplying different signs. Multiplying different signs means it is negative. Notice these problems are similar. Up here, the 4 was negative. Down here, the 16 was negative. For multiplying and dividing, remember, it does not matter which sign is negative, which number is negative. If they have different signs, it's always negative. Different signs, always negative. You only look at the larger number for adding and subtracting. This last one here, 4 minus 16. 4 minus 16, well, I don't know why I'm coming over here. They're different signs, so I have to subtract. You can subtract 16 minus 4 in your head. That would leave you with 12. And then we're going to keep the sign of the larger number. 16 is larger, it's negative, so my 12 will be negative. For 4 minus 16, it's an addition subtraction problem, so you can think about money if you like doing that. That's like me saying my bank account says I have $4, but I spend 16. I have a debt of 16. Well, that's going to put me into the negative, right? That's going to mean I'm negative $12. Hopefully you found this review helpful. Like I said, when we are in school, we give students a lot of practice on this. If you have any friends who have come to the school before, if you ask them, they probably can tell you, oh yeah, I had to do a ton of practice on that when I first started, because it's challenging for a lot of students, and that's okay. But if you find it challenging, please reach out to us and we will give you extra practice on this, or come to tutoring and we can make up some more practice problems for you to do. But at the end of the day, you do want to get stronger at this skill and feel more confident at this skill, because negative numbers make up half the numbers in math. And so we do this at the beginning of the class just because it's not going anywhere. It's not going away, right? We're gonna have negative numbers in all of our math problems from here until the day you graduate. So we do wanna make sure you're feeling good about this, because you're gonna see a lot of negative numbers. So get the practice now while we're talking about it, so that you can be real confident on these problems when you get to the algebra class. That is all I have for you today. So thanks so much for watching. Bye.